So what happens when your system isn't just failing, but is actively trying to destroy itself? We're going to dive into a real-world engineering crisis that unfolded just like a high-stakes detective story. It's a tale of two systems locked in this deadly embrace, a whole series of dead-end investigations, and the one tiny clue that finally cracked the whole case wide open.
Okay, so picture this. You look at your dashboards and they are just screaming red. It was the perfect storm. Not one, but two absolutely critical systems, your Node.js app servers and the primary database, are both pegged at 100%. And this isn't just a flicker. This is a total catastrophic system collapse. And here's the craziest part. Every single time they restarted the servers, they would just immediately crash again. It was this vicious cycle, a feedback loop that seemed impossible to escape. The team even had a name for it. They realized they were trapped in a death spiral. To solve this, you can't just treat it like a bug. No, you have to treat it like a crime scene. The team set up a war room, and every single component of the system became a potential suspect. The hunt was on. So you start with the usual suspects, right? The team drew up their initial list of culprits, the most logical, plausible explanations for this kind of spectacular failure. And the investigation kicked off right here. The first and most obvious place to look was the code itself. I mean, you see an out-of-memory error, your brain immediately screams memory leak. So the team spent hours, and I mean hours, wrestling with these massive heap dump files, searching for that one rogue piece of code, an unclosed listener or a global variable that was just hoarding memory. But after all that digging, nothing. The verdict was in. Yeah, they found a few tiny leaks, but we're talking kilobytes, not nearly enough to bring down the whole system. The code, for the most part, was clean. This was their first major dead end. So, the investigation moves on. Okay, what about a rogue CSV upload blowing things up? Nope, the logs showed that function wasn't even being used. A slow Redis connection? Maybe. Nope, latency was in the milliseconds. 2 more suspects cleared, 2 more dead ends. The frustration is building. So, with all the most likely culprits ruled out, the team finally turned their full attention to the one component that had been screaming the loudest from the very beginning: the database. I mean, its dashboards were just a solid wall of red. Something was deeply, deeply wrong over there. And bingo, they hit pay dirt. The slow query logs showed queries taking 10, 20, even 40 seconds to run. Insane. The team jumped on it, optimizing the code, adding indexes. They deploy the fix, and the system lasts a little bit longer, but then it crashes. Again. Same out-of-memory error. They'd only treated a symptom, not the root cause. Okay, at this point, they're frustrated, but they're not giving up. They took a step back, they stopped looking at individual components in isolation, and started looking at the entire system timeline. And this is where they finally had the breakthrough.
This slide right here, this is the eureka moment. When they put the two dashboards side by side, the pattern was just undeniable. First, the database CPU spikes to 100%. Then, literally a split second later, the Node.js server memory spikes and the server crashes. It was this perfect, devastating echo. And that's when it finally clicked. The team realized they weren't fighting 2 separate fires. The database overload and the memory crash, they weren't 2 problems. They were one. They were locked together in a single, destructive feedback loop. So how in the world did this actually work? Let's break down the mechanics of this death spiral, because it's fascinating how a slow database can make a completely different server run out of memory. It all happens in 4 stages. First, the trigger. A few slow queries max out the database CPU. Second, the trap. New requests come into the Node.js servers, which now have to sit and wait for that overloaded database. Third, the memory hold. That await call to the database, it never resolves. It just hangs there, and every single hanging request holds onto a little piece of memory. And finally, the boom. Thousands of these requests pile up, their combined memory usage just skyrockets, and the Node.js server crashes. And we're not talking about a few requests here. At its peak, there were 10,000 concurrent requests, all trapped in memory. Every single one is holding its own context, its own variables, its own closures. On their own, they're tiny, but together, they create a memory footprint so massive it takes the entire server down. Then, the server restarts, gets slammed with new traffic, and the whole cycle starts all over again. But once you understand the spiral, the solution becomes crystal clear.
The answer wasn't to just throw more RAM at the node servers. That would just be a bigger bucket to fill. No, you had to break the cycle right at its source. And the fix was surgical. The team went in and rewrote those poorly structured queries that were the original trigger for this whole mess. Specifically, they had queries with these excessive left join operations that were just crippling the database. By optimizing them, using some strategic indexing, they slashed the database workload. And just like that, by fixing the database, they released all that pressure on the Node.js servers. The await calls started resolving instantly again, requests stopped piling up in memory, and usage went right back to normal. The death spiral was broken. Stability was finally restored. Now, this whole ordeal, as incredibly stressful as it was, taught some really valuable, if painful, lessons about debugging these complex, interconnected systems we all work with. So what are the big takeaways here? First, always look beyond the error message. An out-of-memory error doesn't always mean a memory leak. It can be a symptom of slow I/O somewhere else. Second, don't just throw resources at the problem. Adding more RAM here would have just been a really expensive Band-Aid. Third, you have to think in systems, not silos. A problem in one component can cause a totally different one to crash. And finally, embrace the dead ends. Every suspect you rule out gets you one step closer to the truth. This whole story is just a powerful reminder of how systems we think are separate can actually be locked in these hidden, fragile dependencies, and it really leaves us with a critical question to think about. Where is the hidden spiral in your system?